In the early years of World War II, Allied supply ships were vanishing into the ocean without warning. Massive steel vessels Liberty ships would suddenly snap in half mid-voyage. Crews barely escaped as ships tore apart in calm waters, not even during storms. At first, commanders blamed German U-boats or hidden mines, but survivors swore they heard no explosion, just a groaning sound before the ship cracked. Engineers were baffled, unable to find clear evidence of attack. By 1943, more than 200 ships had broken in two, costing countless lives. The Atlantic seemed cursed, devouring Allied lifelines to Europe. Wartime urgency demanded quick answers, but time was running out. Factories kept producing ships, but morale was sinking. And then, amid the chaos, a shipyard welder saw something others missed, a man whose ridiculous idea would change shipbuilding forever. American shipyards were the heartbeat of the war effort. Men and women worked around the clock welding Liberty ships together. These ships were the supply veins keeping Britain and Allied armies alive. They carried food, fuel, and weapons across submarine-infested waters. Speed was everything. Each ship built in a matter of weeks, but the rush meant quality sometimes suffered. Steel plates were welded instead of riveted to save time. Welding was fast but brittle under certain temperatures. Still, no one dared to slow down the war machine. To the workers, cracks and breaks were just part of the job. One such worker, a welder named Constance Tipper, began to ask why, and her curiosity would ignite a scientific revolution. Reports poured in of ships snapping in half even near harbor. In one chilling case, a Liberty ship broke cleanly at its dock. No torpedoes, no storms, just a horrifying metallic snap. Steel fragments revealed jagged, glass-like edges instead of torn metal. Scientists realized something deeper was wrong with the material itself. Shipbuilders tested plates under normal conditions. Everything seemed fine. But in the freezing Atlantic, the story changed entirely. The cold turned the metal brittle, almost like glass. Welded seams provided no flexibility against sudden stress. The hulls couldn't bend. They simply broke. An invisible enemy had been found: temperature. And one ridiculous idea soon turned into salvation. At Cambridge University, a metallurgist named Constance Tipper studied the problem. She wasn't a soldier or admiral but a scientist with a welding torch. She noticed that fractures followed welded joints like a trail of destruction. Engineers dismissed her theories as nonsense. After all, how could welding, a war hero's tool, be the culprit? But Tipper persisted, studying steel samples under microscopes. She tested how they behaved in cold conditions. What she found was shocking. The steel's ductility vanished in the cold. It stopped bending and started snapping. Her lab experiments perfectly replicated the Liberty ship failures. It wasn't sabotage or design, it was science, and her discovery changed everything about naval engineering. Tipper developed a groundbreaking experiment to prove her theory. She created a small steel bar and cooled it below freezing. Then she bent it gently and it shattered like glass. Her test became known as the Tipper test. She demonstrated that below a certain temperature, steel becomes brittle. It wasn't about strength, it was about temperature transition. She coined the term ductile brittle transition temperature. Her findings stunned the naval engineering community. She showed that not all steel was suitable for cold seas, and that welding, while fast, worsened the problem. The Tipper test became the key to saving thousands of lives. But getting the military to listen was another battle. Despite her proof, the Navy brass refused to accept it. Many dismissed her as just a woman with theories. They argued the ships were fine, just unlucky. But as more ships split in half, her evidence grew undeniable. Tipper demanded to inspect damaged hulls herself. At first, guards laughed at the idea of a woman in coveralls. She ignored them, torch in hand, cutting samples from wrecks. Her meticulous reports piled up, filled with photos and temperature data. Eventually, a naval review board summoned her. With calm precision, she explained the metallurgy of disaster. By the end, silence filled the room. The admirals finally nodded. Fix it. Fast. Once Tipper's findings were accepted, shipyards changed overnight. Welders were retrained to modify their techniques. They introduced crack-stopping features into designs. New steel alloys replaced the brittle ones. Hull seams were reinforced with rivets in key places. Even small temperature controls were added in welding areas. Suddenly, the fracture rate dropped dramatically. Ships that once split under stress now held firm. The morale among workers soared. They realized they weren't just building ships, they were saving lives. Tipper's ridiculous idea became gospel, and her test was adopted across allied nations. By 1944, the improvements were undeniable. Newly built Liberty ships no longer fractured at sea. Crews reported smoother, safer crossings through the icy Atlantic. Supply chains stabilized. Fueling the Allied advance in Europe, every shipment meant food for soldiers, fuel for tanks, and hope for civilians. The Battle of the Atlantic began to tilt toward victory. Tipper's research quietly powered that shift. Her name wasn't shouted on radios, but her work saved lives. For every ship that reached port safely, she was there in spirit. Her theory transformed shipbuilding science forever. Welding became an art of precision, not just speed, and the war's tide began to change. When peace finally came, the world celebrated its heroes. But Tipper's name was largely left out of history books. Her contribution was buried beneath medals and politics. Still, those who knew her work called her the lady who stopped the brakes. She returned quietly to teaching metallurgy at Cambridge. Her students learned that steel could be as temperamental as people, and that courage sometimes comes not from battle, but from belief. Decades later, engineering journals began rediscovering her reports. The data she collected still holds up today. Her Tipper test remains part of modern ship design education. Finally, recognition began to surface like a ship rising from the depths. The world started to remember her name. Today, her principles guard the safety of ships, bridges, and aircraft. Engineers calculate temperature thresholds before every design. Her discovery birthed the field of fracture mechanics. It became a cornerstone of modern material science. Even spacecraft engineers cite her research on metal fatigue. From Arctic tankers to NASA's rockets, her legacy endures. After the war, the British archives filled with millions of forgotten documents. Among them were Constance Tipper's reports, stamped confidential, 1943. For decades, they gathered dust and silence. Engineers moved on to new wars, new machines, and new alloys. But inside those folders were the blueprints for modern safety design. Her studies of temperature, pressure, and fracture shaped hidden policies. Each chart told a story of pain turned into progress. When historians rediscovered them, they found meticulous hand-drawn graphs. The curves of metal stress were as elegant as poetry. They revealed a woman decades ahead of her time, and her words on one yellowed page stood out. Steel breaks when faith and flexibility is lost. By the 1960s, young engineers began revisiting her work. They tested her formulas with modern machines and found them flawless. Fracture mechanics became a standard subject in universities. Tipper's test was replicated in classrooms from London to Tokyo. Students learned that steel wasn't just strength, it was behavior. They discovered that even the mightiest structures could fail quietly. Her principle, respect the metal, and it will respect you. Documentaries began to surface, showing her calm voice and precise movement. She spoke about ships as if they were living beings with temperaments. Each lecture ended with a simple truth: we must listen to materials. Generations of scientists carried that wisdom forward, and her test became a ritual of engineering discipline. By the late 20th century, Liberty ships became museum relics. Visitors walked their decks, unaware of how fragile they once were. Guides spoke of convoys, storms, and submarines, but rarely of steel. Yet those ships stood strong for decades. Long after their design life, they survived hurricanes, ice, and even nuclear tests, all because their builders learned from one woman's stubborn pursuit. Every rivet and weld carried her silent influence. When the U.S. Maritime Museum opened a Liberty ship exhibit, they placed her name quietly beneath the hull diagrams. A small plaque read, "In honor of Constance Tipper, the woman who listened to steel." Visitors paused, reading the words, often twice, and the ship seemed to creak in quiet agreement. Throughout her life, Tipper fought the quiet wars of recognition in a male-dominated world. Her breakthroughs were often credited to others, but she never sought fame-only truth. Her notebooks, now preserved at Cambridge, reveal her dedication. Equations mixed with sketches of ships, waves, and weld seams. She treated metallurgy like art, every fracture a story. Her letters to fellow scientists show both fire and patience. "Men think I seek victory," she wrote once. "I seek understanding." When her obituary was printed in 1995, few outside science noticed, but her students wept, calling her the Steel Whisperer. For them, she was more than a teacher, she was a compass, guiding future engineers toward humility and creation. Today, every ship that crosses the Atlantic carries her unseen legacy. Her discovery lies not in textbooks, but in the strength of steel itself. When storms rage and hulls hold, her voice echoes in the creak of metal. It's the sound of science protecting human life. The Liberty ships that once split now symbolize resilience. They remind us that even the smallest observation can rewrite history. Constance Tipper proved that intellect and courage know no gender, that knowledge born from empathy can save thousands in every shipyard and engineering lab. Her ghost still guides steady hands. A welder with a torch and a ridiculous idea changed the war's course, and her legacy sails on strong, silent, and unbreakable. The Atlantic never claimed another Liberty ship again.